All right. So, as everyone is joining, do advise we could for the meeting, because it's actually going to be a very interesting one today. I do advise everyone, if you can grab a notes. This is very foundational aspect of our program, because we will be practicing this as we are going ahead to do the actual design work in software. So I believe this topic is something that we always need to go over when we start a workshop program like this. So if you have a note, I do advise that you get one and a pen as well to jot. If you have a tab that you can jot in apart from the main screen that you're using, so you don't miss out, you can do that as well. Once again, welcome everybody to the meeting. We'll start quite shortly. I believe I will have a timer on the second screen over here. So as we are here right now, just to lay out some general ground meeting items. So if, for instance, at any point in time you have a question, please feel free to relay it in the chat box. Okay, I will try my best as possible to answer questions when we go through breaks. We would also have more or less like a 5 minute intermission, um, probably between 30 minute intervals, so to make us have a breather in between the meeting. All right, so also as well, I also want to point out that this meeting will also be recorded, so if at any point in time you want to refer back to it, you can. It's going to be a 2-hour meeting today. I look forward to having everybody participate fully. Also as well, I will also kind of repeat this when we are at our 30-minute intermission. As much as possible, rather as much as possible, to show participation in the program, everybody has been assigned a drive folder, and you notice inside that drive folder we have an attached logbook for each participant. So for every single day such as this one, you are to document what you've done on that day, such as what you've learned, what you've practiced, or what you've adopted or shared with others as well. So please, like I mentioned in our first meeting, participation is very vital, so make sure you actually go ahead and fill in that. Also, your progress will be tracked daily to be sure that you are following. All right, so welcome again. We would start shortly. I believe the timer is almost to his last second. Okay, let me see. Okay, so we have some people. All right, we have quite a number of people still joining. All right, so while we wait for everybody joining, let me just quickly greet. Okay, so we have Anthony. Anthony, welcome. We have Monet, welcome. Rodriguez, welcome. Victor, Juma, welcome. Wasike, welcome. All right, great. I think I saw a Deborah. Probably she stepped out for a bit. All right, so welcome everybody. All right, so let's just give 2 minutes 2 minutes timer. Let's see. All right, so in 2 minutes we would start effectively, just to make sure that everybody joins in the right time. We want to make sure that we don't miss anything vital. Okay, all right, great. So probably as we wait the 2 minutes, let's see if everybody has any questions so far. I do hope we've all been integrated to the Slack workspace. Is very vital, as well as also being able to connect your Google Calendar to it. That way, you can focus more on working on the Slack platform without jumping from one app to the other. All right, so it's done in a way to make sure that we can focus and concentrate. All right, so yeah, if you have any questions on that, you've not been integrated, feel free to let me know. I'll be able to guide you on that probably later on during our consulting hours. And then also as well, just another reminder to make sure that you set up your Autodesk Student license, because I mentioned this program is going to be more on hands training and in the design and design aspect. So please make sure you have your Autodesk Student license set up, as well as also downloaded the Revit application and the Robot Structural Analysis application as well. Okay, this is very vital that you have those applications set up. All right, so we're down to the last 30 seconds. All right. Okay. So, all right. So let's start the meeting officially. Okay. So, uh, go ahead and greet everybody that is present with us here again. Let me see. We have Anthony. Anthony, welcome. All right. We have Monet, welcome. Rodriguez, welcome. We also have Victor over here, and we have Wasiki over here. All right. So we would be expecting others as the meeting progresses. Okay, so just like I advised earlier on, if you have the notes, feel free to jot as well. We'll also make the recording available. Okay, so while you're at it as well, just feel free to send the message to the chat box. Just say hi to make it a warm environment as we start. Okay. All right. So once again, my name is Ayomide Akinrade, and I'm the lead supervisor for this design workshop program in association with ACSKU, that is the Association of Civil Engineering Students of Kenyatta University. Right, your prestigious university, and we are going to be kicking off this program, today's program, with basis of structural design. Basis of structural design. Now, this is very vital because without this knowledge, we won't actually know exactly what to do once we start. All right. So, for instance, if you want to design a beam, you need to know what needs to go in a beam, before we go ahead and design it. What determines the section properties such as the depth of the beam, the width of the beam, all of that information. And what I've done is that I've been able to break down this meeting into some agendas. Okay, so like I said, basis of structural design is vital, so I've gone ahead and listed some things over here, and I'm trying as much as possible not to make it a slide based training, or rather program or seminar today. And the reason for that is that I want to show everybody practically how these things work. All right, so let me quickly pull out the outline over here. And what we want to do is that we want to start with uh, structural elements. Okay, so structural elements. Okay, all right, good. So now I'm going to be illustrating this with actual models. So for instance, let's start talking about elements such as beams. Okay, so I'm going to be switching to another screen over here. And if I, like I said before, if at any point in time you have any question, just feel free to let me know. Okay, all right, good. So we have this over here, this screen, and we have various types of structural elements. If I must mention, please give me a minute. I want to dock my screen so I can see both the Google Meet on my second window. All right, great, better. All right. So we have various types of structural elements, and all of the structural elements are responsible for making a building stand. All right, and they have different configurations. The configuration is probably the last thing we'll talk about today, but let's start from the smallest. And you can see here that we have quite a number of models over here, and some of them are actually replicating buildings, but you can see towards the left side, top right side of our screen, we have the more complex, but we break it down, and this is basically how engineering is meant to be. We should be able to understand it to the smallest detail before thinking about going over to more complex structures. So let's start over here. I'm going to scroll over here, and we're going to be talking about beams. Okay, please, I just want to confirm if you can see my screen. Let me know if you can see my screen. Just let me know. Just say yes in the chat box, so I'll know that we are all following. All right, so if you can see my screen, just let me know. All right, great, thank you. Oh, okay. Deborah says she can't. Okay, just want to be sure that she'll be able to see it. Okay, Deborah, what about now? Can you see the screen? Just want to confirm. All right, great, thank you. All right, okay, yeah. So let's go ahead and continue, right? So we're going to start with beams. Now, many of us have actually come in contact with beams before. You've probably seen, maybe probably in a large classroom, you've seen a beam just spanning across the whole building from the top, as if you're looking at the ceiling, right? And what a beam ideally does is that it carries some of the loads from the building, such as the slabs. So for instance, if you're on a top floor, you're on a suspended floor slab, right? A suspended floor slab could be something like this, for instance, okay? And then you can see that this slab over here is actually carried by a beam, right? And now these beams basically carry majority of the loads of the slabs, and then it transfers it to the columns, which send it to the foundation, right? And that's basically some of this. That's a simple one of the simplest ways to explain load takedown. So let's understand how beams work. Now you can see that I'm going to start here with material and section sizes. Okay. Now beams can come in different sizes. So you can see here that over here we have beams of different sizes. We have a 300 by 300 mm beam, right? We have a 300 by 600 mm beam. We have a 300 by 900 mm beam. And you notice that it is increasing in the depth. Okay, so for instance here, this one has a 300 mm depth, this one here has a 600 mm depth, this one here has a 900 mm depth. All right, likewise as well, the same thing on the other side as well towards the right. But you can see these two have different they have different materials. So for instance here, this one has a C20 concrete material type, this one has a C40 material type. Okay, and this is what we refer to as grades of concrete, right? Most of the time, or rather to make it or to explain it in the simplest terms, the higher the number, the more the cement ratio in the concrete. Okay, that's kind of the best way to explain it. And what you notice, probably if you've done materials in school, probably in your second or your first year, you know that concrete being a binding material, it tends to make the material stronger, especially when it comes to elasticity modulus or the strength of the material itself. All right, so we have different grades of concrete. We have from C20, 16, 25, 30, 35, 40, all the way to 60, 90. So those are higher grades of concrete, right? And now we need to understand what is the choice, or what is the reason for picking a particular material for concrete. Now let's ideally look at it in this way. Okay, now let's compare these two concretes together. Okay, so we have one of 300 mm, we have another one of 300 mm. Okay, I'm going to just kind of isolate this in my application. Like I said, I want to make sure that this is as practical as possible. All right, if you have any questions as well, just let me know. Now what I'm going to do is that I'm just going to come over here and show you some of the analysis details. Okay, give me a minute. Just want to set something up to make it a little bit simpler to view. Oh, okay, sorry about that. So I should ideally be showing you another screen. That should be okay. Yeah, better. Yeah, this is what I want to show you. So I want to ask, we are all kind of familiar, especially if you started doing this in school, structural analysis. I want to ask if you're all familiar with structural analysis, right? So free body diagrams such as this. Just want to ask if you're familiar with this, just let me know by a response in the chat box. Familiar with this? Okay, Deborah said yes. Okay, great, thank you. Okay, let's just be certain. Okay, Monet said yes as well. Okay, great. So this is vital. You'll notice that this is one of the first things that we do in school once we start our core engineering and civil engineering course in structures. So we have to assume the structure is a free body diagram like this. So if it's going to be a beam, it will most likely be a horizontal member such as this, and then it will have supports at the ends. Okay, all right, so now let's assume we've gone ahead to analyze it. Now this isn't a program about analyzing structures, but if you're interested in that, just let me know. The kind of send you guides and resources to learn on that. All right, okay, so now let's go ahead and look at how this thing works. Now what you will notice is that between the two differences with materials here, the one that has a higher material would less likely have smaller displacement, so meaning that it's not going to show visible displacement when it is loaded, right? And I'll show you a good the representation. So for instance, let's go ahead and look at the displacement on this structure. So I'm just going to turn on the diagram to see that. So it's loading up. All right, great. So I've turned on the displacement, and this is basically like a map. Let me see if I can increase it, the scale. I want to be sure everybody can see this properly. All right, so all of these structures or beams, they've been loaded, right? And now you can see that they now have displacement values towards the center of the beam. Over here, for instance, even though this particular beam here is a 300 by 300 and this one is 300 by 300, you can visibly see that two of them here have different displacement values, right? One here has 0.27 and this here is measured in millimeters. So in this sense here, we're saying that materials or members with smaller sections, I mean smaller sorry with a, how do I put it, a smaller concrete material or a lesser grade of concrete, so the words are coming out better now, with a lesser grade of concrete are going to have larger displacement. So this is about 227 mm displacement compared to this 23 mm displacement, just because of a change in material. I can see the same thing as well also in different sections, but you notice that the larger the section, the smaller the displacement, right? The larger the section, the smaller the displacement. And just to show you how that looks like, let's go back and look at the physical elements. Okay, let's go and come back and reset this. So we can see here that this one here is now thicker than this one over here, meaning that these ones have a better, they have a better performance in resisting loads without having large displacements. Okay, so that's exactly how it works. And then the larger it is, you can see here 600 compared to 900. If you come back here to look at the analytical model, you can see here that this one is almost negligible. It's almost like about 1 mm in displacements. Okay, so that's a good way to actually illustrate it and show how the difference between materials and properties work. Now, displacements are not the only things that we check when we are going to deal with beams, for instance. Okay, we also want to check some other things such as bending moments, right? Now, majorly, most of the time, bending moments are what we use in the design of vertical members such as beams. Okay, and let's go ahead and look at it. I'm going to come and just isolate this up. And if you're wondering what software I am using to do this, this is Revit. We'll get to a point in the training where I actually show you how to do things such as this. Okay, all right, good. So now let's go ahead and look at the moments for these beams. Okay, now let's start with this one. I'm going to go over here and turn on the moment for the beams. So let's go over here. So by the way, I have a model that I'm working on my second screen to show some of these results, but I want to make sure that it's not overwhelming, so I've not decided to cover how I'm doing this right now. All you need to do is just focus on what is happening. Okay, so let's go over here. I want to look at the moment on the beam. All right, good. So loaded. Okay, great. Let me increase the scale a bit so we can see this better. All right, good. So we can see here that this is the moment generated on the beams, and you can visibly see that all of these are simply supported beams, meaning that they have one support on one side, another support on another side, right? And we can see that even though these two beams here have the same section but different materials, they will still have the same moments. Okay, so the material ideally does not affect the bending nature of the beam. It is the material would affect the displacements but not the bending. So that's why you notice most of the time when a designer is designing a building and let's say this 300 by 300 mm is not passing, he may just decide to opt for a larger section instead of going to increase the material, because most of the time increasing the material will come at a more cost, it will be more costly rather, in that sense. So that's exactly how it works. And you notice that the moments will increase with a larger section, for instance. So you can see here that this 300 by 300 compared to the 300 by 600 here has a larger moment. Now, this doesn't mean that it cannot carry the loads. It just means that the moment generator is going to be larger just because the section is bigger. Okay. Likewise, as well, you can see visibly that with 300 by 900, you can see as well that the moment has increased. And you can see it's the same even though the materials differ. So that's a bit about looking at some of the parameters for beams and the nature of how they behave. Okay, now let's go back here. Let me just go and reset this. So like I said before, if you have any questions so far, just let me know. I also advise for those that are just joining, feel free to take notes on what we are doing, because this forms a very large basis of what we would be doing later on. All right, good. Now let's talk about here beams subject to bending. Okay, now let's go over here. We are going to be looking at simply supported beams. So before I continue, I really don't want to make so many assumptions. If you are familiar with simply supported beams, that's how a beam is being supported. Just let me know. If it's a yes, let me see in the chat box, or hear it in the chat box. If it is a no, let me get that in the chat box as well. So let me check. So if you are familiar with how a beam is supported, let me know. All right, so Deborah said yes. Okay, Juma said no. Okay, all right, great. All right, Monet said yes. All right, great. Okay, Antonio said yes. Okay, all right, great. So all right, so for the sake of those that didn't actually understand, so let's explain it how it works. So we can see that over here we have a beam. Now let's look at something in this nature over here. If for instance I had this structure, let me go ahead and just delete it for explaining it in a better way. All right, let me just delete this. I'll bring it back. Okay, so look at this beam over here. When we say a beam or a structure or element is simply supported, it means that it is supported on both ends like this, right? So this is what it means for a beam to be simply supported. Now, because we'll go over to another section, when we say a structure is cantilevered, it means that it is only supported on one end, so it's going to look something like this, meaning that it is supported just here, but it's not supported on the other end. Okay, so just use that small illustration. Let me bring this back here so we don't we're not missing it when we need it later on. All right, great. So this here is a simply supported beam. And now beams also have what we call support conditions. Now, understanding support conditions is something we may not cover in today's course. And support conditions basically define how the structure is going to behave and its stability as well. You would also notice as well support conditions will determine whether a building will be statically determinate or indeterminate in nature. We don't want to go too deep into that here, but it actually affects how the structure behaves when you look at the analysis. So let's look at this one here. Let's assume it is pinned to pin. So both ends, so the first support is pinned, the second support is pinned as well. What that means is that it is restrained in two directions, but it is allowed to rotate at both ends, right? So that means it is restrained both in for this point here, it's restrained in the let's say in the Z direction, and it is restrained here in the Y direction. Okay, likewise as well, it is restrained in the X direction, in the Y direction, it is restrained in the Z direction, but it is allowed to rotate, meaning that it can rotate like this and it can rotate like this at this end. So that's what it means for it to be pinned to pinned. So let's look at its resulting analytical model. So let's go back here, for instance. So beam is subjected here. Let me go ahead and isolate these elements. All right, good. All right, great. So let's go ahead and look at its bending. So just like we saw before, I'm going to go over here and turn on bending over here. All right, great. So we can see here that the one that is simply supported pin to pin, we can see here that we have the maximum bending at the center of the beam, right? Can we see this? The maximum bending at the center of the beam. And let me see who can guess what the formula is. The formula is to calculate the maximum bending in the simply supported beam. So if you know that, just type it out in the chat box. Let's see our academics over here. So if you know what the formula is for calculating the maximum bending at the center of the beam, you can type it out in the chat box. Okay, so let me go ahead and increase the scale. I want to make sure that we can see this a little bit better. Very good. All right, great. So we can see here that over here we have what 63.42, and this is based on a load that is actually applied on the beam, right? So we can see here that there isn't anything where it is supported. This is a pin support, this is another pin support, so you can know by the icon. Okay, so there isn't any moments generated here because it is free to rotate. Okay, but let's look at something else here. Simply supported fixed to fixed. So if this one is pinned here, this icon here is going to be referring to a fixed support. Now fixed support ideally mean that it is allowed to, it is restrained in both Y and Z direction, and then rotation is not allowed as well. Now you notice wherever rotation is not allowed, moment will be generated at that support. I can visibly see here that there is moment at the support, and you can see through the nature of the bending diagram, right? So we can see here that here, compared to when it was pin to pinned, the moment at the middle of the beam here is smaller compared to what it is at the support. Now there are other formulas as well used to calculate it when it is fixed to fixed as well, and there's also a formula. Okay, all right, good. Now let's look at another one here. We can see this one here is another simply supported, but this time around over here it is fixed and over here it is pinned, right? And you can basically see a combination of everything that we've learned so far. We can see here that because it is not allowed to rotate here, moment is generated at the support, but at the other pinned end here, you can see here that there is no moment. Now, why is all of this vital? Most of the times when you are using software to design, you want to be sure that it is accurately depicting what you want it to do. When it comes to engineering, there's quite a lot of assumptions based on theoretical models that have been created by different people that have worked on these models in the past. And you can tell by looking at the analytical models such as this that, okay, this is behaving exactly how I want it to behave. You can also use this as well to quickly check for errors in your modeling as well. So for instance, now let me just give you a quick example. If I actually model the beam to be fixed to fixed, right? When I'm looking at my analytical model and I see here that it is showing this diagram, it means that I may have made a design error, or rather modeling error, by not changing this one here to a fixed support. So understanding how these structures behave under loading and how the analysis is generated is very vital. Okay, all right, great. So that is just for being subjected to bending. We're going to look at another one just shortly. All right, so at this point here we are at a 30-minute interval. How time flies. All right, so at this point here we would take a maybe a 1 minute breather, and if you have any questions, feel free to let me know now. Okay, all right, great. So once again, welcome to everybody that is just joining us shortly. We are currently looking at structural elements and how they behave under loading, and as well their analysis results. Okay, so if you have any questions, feel free to let me know, and we will start off in the next 1 minute or so. All right.